Hello and welcome to another video. This one I'm hoping to show you how you can it's called an affine transformation, but the equivalent is do a georeference for vector layers. So I've come up with a pretend example. Often you'll be asked to do a survey of a site or something, and the client will provide you with a lovely PDF showing where the site is. And if you zoom in or zoom out, you'll be able to see whether the PDF is a vector image or a raster image. A raster image is like a bitmap where every single pixel is told to have a particular color, and a vector image is one where the computer just remembered that this point is that is distant from that point, and to draw a line between them. So, for example, I have made this mock-up of Stonehenge as a vector image. If you zoom in, the line just stays nice, crisp and clear. By way of contrast, any old minute, here's the same thing as a bitmap image, and as you zoom in, it gets fuzzier and fuzzier and fuzzier. I find vector images very useful to use. It means you have to do less drawing. Sometimes it means you can snap to stuff. And this method took a bit of figuring out, but now we're there. It's pretty simple to use, I think. So first up, to get a vector image into QGIS, the best way to do it, I have found, is using a plugin called DXF Import Convert. So somebody very brainy has made this thing that allows you to import DXF files. DXF, as far as I know, is some sort of CAD-based thing. Often, if you get sent a CAD topo drawing or something like that, it'll be in a DWG format. There's plenty of online services that can convert DWG files to DXF files, and there's also a program called OpenCAD which you can use, and that'll do it for free. You just click on Save As DXF. But assuming you've been given a PDF, where am I up to? Here's our PDF. So I'm going to right click on it, open with, and then I've already downloaded this program, but this is the program I'll be using. It's called Inkscape. Again, it's open source, it's free. Is it a Photoshop knockoff? I don't know. Anyway, it's dead good. So it takes a little while to load, on my computer at least. Here we go. Just click on OK. And all we're going to do is File, Save As, DXF. I don't know what the difference between these two versions of DXF is, but it seems to work well enough with R14, so that's what I'm going for. So we're going to save that. Okay. There are things you can sometimes do in Inkscape to simplify a PDF that a client sent you. You can select by colour sometimes. You can remove things that aren't relevant by selecting things. And it's worth having a play and finding out how Inkscape works as well, but that's beyond the scope of what I was hoping to be a reasonably brief tutorial. Anyway, we have now got a saved DXF drawing. So we're going to be able to put this DXF drawing into QGIS. The issue being, it's going to put it in at the wrong size and in the wrong place. Most of the PDFs that you get from clients, and to be honest, most of the topo drawings that I've ever been given, don't have any form of like geographical location data within them. Sometimes you're really lucky and you put something in and it goes in at the right size and the right shape, and that's marvelous. Most of the time, it's got no coordinate data on it. So when you put it in QGIS, it doesn't know what size to make it, and it shoves it somewhere off the south coast, right at I suppose it's the 0, 0 coordinate reference. So let's show that. We're going to go vector, DXF import convert, browse. There's my DXF file, open. You can play with all of these things. I'm sticking with save as shape files. Use basically have a play with these functions and find out what works for you. I've sometimes wondered whether this would negate some of the steps that I'll show you next, but I've never been able to work it out. Import. It's saying overwrite the following files because I've already done this once to make sure it works before I made the video. Normally it doesn't do that. So close. On the surface, nothing's happened, but you might notice a small dot has appeared down here. If we zoom down to the bottom of this, if you notice it's made us 2 layers in a little folder. Both have question marks because they don't know what coordinate reference system it is. One's for points, one's for layers. Not interested in points because I didn't make any points on my thing. I'm going to change. I'm going to click on the question mark and change the coordinate reference to British National Grid. And then let's right click and zoom to the layer. So you can see it's made our layer somewhere off the southwest coast of Britain. And I'm not going to show you it's the wrong size, but just bear with me, it's the wrong size. So as you would do with a georeferencing layer, I'm going to measure 2 points on here, and then we can measure them as they are in reality and make it the right size. There are any number of ways of doing this. I'll talk about it later in greater depth, but let's show the principle to begin with. I've made myself a little Excel sheet that has right size and wrong size written on it. This just shows the ratio is going to be the right size divided by the wrong size. And as you would do with a georeference, it's just better to find 2 nice clear points somewhere on the ground that ideally, if you imagine like buildings, if it was a really tall building, then that can throw off your coordinate reference. So if you can find like where a path joins another bit of thing, that's normally best. So I'm going to pick this corner here and that corner there. I'm going to measure the wrong size first. And that is measured as 257 meters. So let's copy that and paste it into there. And then we're going to zoom to the Stonehenge, and that'll show us the right size. I've already typed in the postcode. Looks clear if I remember, if I'm honest. So that corner there, to that little feature there, and that's 187 meters plus change. Wait, did that wrong. Right, so that's the right size, the wrong size, there's the ratio. And we can use that to get our PDF to the correct size. Let's turn that off and zoom to our incorrectly sized layer. Now, to get this to the right size, we're going to do a Affine transformation. I'll turn this off. Whoa. We'll go back to basics. You go into the toolbox. You can also get to it from there. It's locked away in the Saga set of functions. Vector general. Transform vector layer. So that's the one that we want. You could also get to it by typing in transform. That'll bring it up. And also recently used. Once you've used it once, it'll be recently used. That's good. First thing, make sure that the shape that we're going to change the size of is the correct one. That is. And then we've got the scale factor X and scale factor Y. And all we're going to do is paste in ratio we got from there. Open output off the file in algorithm. Yeah, that's all good. Run. Wait a little while. My computer is in fairness being quite slow today. Not really sure why. And it's done it. So let's close that down. And we can see we've got a new layer. It's called it out. I'll turn it off and on so you can see, and it's a much different size. Now we just need it to be in the right place. What I had done until recent. Oh, and remember to save, because there's nothing worse than getting halfway through something and having it crash. What I had done previously was just select it all and use the move feature. Pick it up and then zoom to where I want to move it to. I'll just cancel that, which works okay, but on more complex layers, that can be a very slow process. It's sort of like one of those set it off, go away, make a cup of tea, and you don't have to remove it again. So I found another plugin which speeds up the process considerably. It's called Move Features, not surprisingly. So you can go into your management and just Move Features. There we go, and it'll make this little thing for you. So let's click on it. Features to be moved. And we're going to select our out layer. Start and endpoints. There seems to be lots of different ways that you can do this, and I prefer the select from canvas one best. So let's choose there, and then endpoint where we want to move it to. Okay. And there we have it. It's moved our vector layer to where I want it to be in Stonehenge. It's a bit of a silly example, and it's a bit of a simple map, but this works really well over even quite large areas and over quite complicated maps. And yeah, it's nice to have things in a vector layer. Various reasons. One, you can snap to all these, so drawing becomes easier. Two, your maps can look good, whether you need to zoom in, zoom out, whatever. And I think, particularly with biodiversity net gain and the need for measuring areas accurately, if somebody's already done a topographical study of a site, it's probably more accurate to try and get their survey accurately georeferenced in than drawing over it as a raster in the background. Once you've already georeferenced it, it sort of removes a bunch of steps. One thing I forgot to say, and if I'm entirely honest, have added in later, remember to save this layer. Once you've got it in place and at the right size, save it as something base plan or something like that. So when you open up your project again, it doesn't disappear. Very important point that I forgot to mention. Other things I was going to talk about, other ways of measuring distances that you can do a little bit more accurately. One thing that is possible if you zoom back to this and turn that off on your original layer, if you bring up your snapping, you can actually snap to points. On this, a useful thing to do can be to create 2 point layers called right size and wrong size. I'll just have these in your template. And then when you come to make your measurements, you've got defined points that you know you've used to measure between. The snapping will also work to the snapping will also work to the points to make your measurements a bit more accurate, which is important. So do that, and then on your right size, you'd simply be again measuring between the 2 points. If you felt that using the measuring tool wasn't quite precise enough for you, you can use the you can find it. You can find the nearest neighbour analysis tool. Which will tell you the observed distance to, I mean, let's face it, if that's a metre, that's a centimetre. You're talking a very small level of accuracy there. And yeah, I've set up a layer for us at ERAP, which basically takes the Excel sheet out of the equation. You put in your right size and your wrong size. Those are from a drop down, and it works conversion out for you. I'll show you the formula, what has got that in it when it opens. There we go. And I can do another video that talks through how to make one of those if people find this video useful in the first place. Hopefully you'll find that useful, and as if you've listened to my other videos, you've been probably hearing me saying this now. If you have found this video useful and you use it in your professional life, please feel free to make a donation to people who make QGIS in the first place. which, it's brilliant that this software is available for free. Or if you'd rather, make a donation to your favourite wildlife charity. And yeah, thank you very much.